good night to all of you. Welcome to the first AYBU ERA seminar of 2021. I wish you a happy new year. Today, I am honored to host Professor Mehmet Caner on behalf of Ankara Yıldırım Beyazıt University and Economic Research Association. I would like to talk a little bit about Professor Caner. He is Thurman Rayton Distinguished Professor of Economics at North Carolina State. He has been a full professor of economics at Ohio State between 2015 and 2019. He was the chair of EC Square in 2018 Big Data Conference in Rome, and also taught summer school to Bank of Italy in 2016. He has taught econometrics as visitor in Columbia University in 2018. His other visiting positions were at MIT in 2015 and Michigan in 1998. Currently, he is guest associate editor in Journal of Econometrics on text analysis, machine learning. He is also associate editor of Journal of Business and Economic Statistics and Econometric Reviews. Today, he will inform us about machine learning, which is a new approach started to be used for economic analysis in recent years. Also, we will be informed about Lasso as a special case. Now, Professor Caner, the floor is yours. We are ready to listen to you.
Thank you for the invitation. So I will just talk informally mostly, and then I will concentrate on Lasso. And then let me just tell what it is just for a few minutes for the persons who don't know that. Lasso is basically least absolute subset selection operator. It's a shortcut. It's a method that can select the model and estimate the model simultaneously. So, I mean, if you go back 20 years, we couldn't have done that. 20 years back, we usually select the model first, or we say, this is the correct model, and I'm going to estimate that. So with Lasso, you don't have to do that. The data will decide what kind of stuff model you might have, and then estimate that simultaneously. So it's a big jump, actually, idea-wise, compared to others, because if you first find the model and then estimate second step, all the mistakes in your modeling stage will go to estimation stage. So this avoids that. And then I published some papers that kind of shows that why that two-step approach in the past is a bad idea, and this one-step approach of Lasso is superior. So I'm going to talk about history and then the perspective. I would like to tell what's going on in research. So I will start with 1996. So I think Tibishirani at Stanford Statistics, he's the founder of Lasso. So he developed this, I think, in a Journal of Royal Statistical Society Series B article in 1996. But I can't remember, but I don't think there was any theory behind it. It was just like an idea and then some kind of simulation evidence that is superior to whatever else is existing, like BIC, AIC at that time, and other model selection and then estimation tools. And then I think in 2000, I have a co-author, Keith Knight, in the University of Toronto Statistics. He discovered in Annals of Statistics the mathematical foundations of Lasso for the first time. So it made a big splash. Because now with Keith Knight's article, we kind of know what are the limits that we can face with Lasso. It came as non-standard limits to maybe as a surprising result. It didn't come out like normal limit or anything. So it came as a complicated limit, but there was a limit. And then the issue is can it be like computationally handled very well? So like, do you have to run to the power p calculations, p being the number of regressors in a simple linear regression? Or like, is there a way to run like p regressions, which will be incredibly simple? And that question was unanswered, I think, around like until 2006. Fred Efron, in a major article, again in Annals of Statistics, kind of found a way to run p regressions instead of to the power p. So he made a huge advancement in computation. So he found a way which is tied to Lasso. It's called Lars, least angular regression. And Lars is basically almost equivalent to Lasso solution. I say almost because it's just like a constant times Lasso solution, and that constant can be estimated very easily. So these are all incorporated packages now. After 2006, after the computational advantage, I should say, Lasso stuff exploded because now it's computationally feasible, and then you can kind of do selection estimation. And a lot of people in Princeton, for example, Fan in Princeton, he started writing articles, and then there are other people, I think, in statistics literature, they discovered something called adaptive Lasso, different versions can do better models than the regular Lasso. So
benim adım Boğaz. Sana benim.
So, I mean, then basically a lot of things have been written. So I started writing in around like 2008. So I published a paper in econometric theory on Lasso type GMM estimators. And then Keith Knight before me published something on least squares I think in econometric theory. So those were, I think, the first like startup articles in economics on Lasso estimation, least squares and GMM by Keith and then me in econometric theory. And then I think Viktor Chernozhikov, he published a lot of very influential articles. So he took everything on a different route. So I think one of the biggest deals in Lasso literature is, which we didn't do. We were concentrated on model selection in our articles, and Viktor concentrated on model prediction in finite samples, and published this in econometric, I think, around like 2011. And I was a referee to that article. It was a very fine article. One of the biggest difficulties that we had, like also like statisticians had, was that you couldn't extend that to heteroscedastic data sets. So Viktor find a way, a new penalty. So to do that. So basically Lasso is a penalized least squares regression. So you have in a least squares world, you have the least squares output, plus you have penalty penalizes the parameters. So you penalize the parameters inside your system. So you fit a large system, you fit like p regressors, and p can be larger than your sample size. And then so we'll select a subset model, which will be approximately correct, and then if you use adaptive Lasso, which can perfectly select the correct model. So, and these are very good properties, and also like prediction-wise, we start realizing that what might end up as improving prediction, what might end up in like making your life worse, and then if the truth is such that you have lots of things contributing the forecast, I think it will be difficult to get a good prediction. This is the upshot of all the research that comes from both statistics and econometrics. So so large system predictions, like if you like to predict something with lots of regressors, and if all of them are contributing really to the output, then the job is very difficult as a forecaster, I think. So this is kind of like the finite sample prediction results. And after, like, Viktor published now a lot of articles. If you look at his CV, Viktor Chernozhikov at MIT, he published a lot of articles with Alex Belloni at Duke here in North Carolina. So they published a lot. And then I think Chris Hansen in Chicago also published a lot. So a lot of things went on to least squares treatment effects. A lot of people are working on so-called treatment effects, randomized trials, and Lasso. I work on generalized method of moments, instrumental variable selection. So I published some of the stuff in Journal of Econometrics, and then as well as Journal of Business Economics and Statistics, and some of them are in econometric reviews, and some of them in stat journals. I published a Journal of Statistical Planning and Inference, to give you an example. And then we try to apply this idea to like partially identified systems recently, and then I had like a postdoc student from Ege University in Turkey, and she took my course and she realized that she can merge something called node-wise regression that I was teaching in my course to finance, and then now we have actually a company set up in Turkey that's trying to form portfolios by using machine learning, and so we are working on these things, and it seems like it's working very well. And then we try to infuse these ideas, and now there's a more of a push also in the finance literature in the last 2-3 years, incorporating machine learning, big data into financial stuff. So there's this effect that too. But all of the explanations that I did involves Lasso estimation. One problem with Lasso estimation, so I kind of went through the advantages. Prediction, model selection is very good. One of the disadvantages is it doesn't have like a very nice limit. You cannot manipulate that as a normal distribution. It doesn't have that. And then it doesn't have any standard errors, so it kind of lacks inference. So you cannot, like, if you're interested in testing things with wall likelihood ratio or Lagrange multiplier test, you cannot do that with Lasso. So what happened next was, and also Lasso is point-wise consistent. What I mean by that is, if the truth, so Lasso differentiates between zero and non-zero element in a regression in a careful way. And the one problem with Lasso is, if the truth is non-zero and near zero, if the small non-zero number is still contributing to your forecast or anything, then Lasso will cut it to zero, unfortunately, and then your regression will be basically underfit. So that's kind of a problem. And so what happened was, like, recently in the last, I don't know, starting in 2014 or around that range, 2015, statisticians Zhang and Zhang, I think in Rutgers, and then Buhlmann and Saravandegar in ETH in Zurich, they find a way to kind of come up with a new solution. So it will add up, there's a bias term in Lasso, it will add up this bias term, and if you add the bias term, you're going to estimate the bias. And when you do that, when you bias correct the Lasso, or we call it debiasing the Lasso, then you're going to get a normal limit. So you create a new estimator based on Lasso estimator, and that new estimator will have limits, normal limits, standard normal limit, and you can have testing, and then you can have inference, you can have confidence intervals. And Saravandegar and Peter Buhlmann, they published this, I think, in 2014 or 16, I forgot, in Annals of Statistics. And I was lucky to see that in a conference, so that I started writing an article with Anas Kok, my co-author now at Oxford University. So me and Anas, we published a paper in Journal of Econometrics in 2018, and how to do this. Second, if you call it like version 2 of Lasso estimation. So we published that in least squares format, and we come up with a new Lasso-based estimator as a startup estimator. So the literature now is heavily in the last 2 years. If you look at new PhD students from MIT and other schools, you kind of see almost a lot of them are in econometrics writing so-called a debiased or second version of Lasso estimation. So the first version is more or less abandoned. And then research is going towards more like second version, version 2, and I'm still writing version 2 type of papers, and that will be beneficial. Of course, the other trick that we are using in finance is like use like a subset of the idea, and then put inside the financial theories, and then try to make some predictions about financial theories. So there are like two. This is what I'm doing as a researcher. But the literature is like the cross-section literature is heavily moving towards panel data, treatment effect, randomized trials, and incorporating them with the debiased Lasso estimation. So Viktor Chernozikov has papers on so-called the same ideas, but he sometimes gets this answer differently than us. So I don't know, they end up with the same limit, but it's just like it's a different motivation. He kind of like, and he calls it Neyman orthogonally partial doubt estimation or double debiased machine learning estimators. So his approach is more on like treatment effect and randomized trials. So I think this is more or less what the literature is going through now. I mean, as a historical perspective. So, like I said, this version 2 type of estimation is heavily dominant in the last 4 years in US and possibly in Europe. So we're going to see a lot of articles getting published or is in working paper stage. In finance, I don't think that's kind of caught up. In finance, they are doing things differently, including myself. We are still kind of like using first version or different versions of machine learning or Lasso in a different way. And I think this is more about Lasso. And I have some time left. And so what I would like to do is, I mean, apart from Lasso, there are other developments, and I teach these in courses, and they're random forests, and then deep learning, and then things of that nature. But one thing that I was really struck by 2-3 years ago, I think, when I was chairing this EC Square conference in Italy, and text analysis, macro forecasting, and machine learning. It kind of like struck me that they're going to make a big difference. A lot of people are working on these things. I was not aware of that much text analysis. Now I'm this guest associate editor in charge of that in Journal of Econometrics. I was able to convince Journal of Econometrics it's a good idea to publish some kind of like special journal, a team that will be based on text analysis and machine learning. It looks like that the main idea is like you kind of like cover the newspapers or financial newspapers, and then try to make a prediction about a certain stock, like say IBM stock. So you cover all the your machine learning, whatever algorithm, so goes through these newspapers and then finds words about IBM stock, and then trying to make a prediction about IBM stock. And I kind of see that this is working well. And then and also, like, there are other things like in macro forecasting, people use text analysis, and like in Switzerland, they formed a company called Centrometrics based on sentiment analysis. So they look at the sentiment of the text, and then they try to predict something from that sentiment towards a certain stock, I think. There are certain ways of doing that. Some people just add up plus minuses. There's certain buzzwords, and you say plus word, minus word, and then you get an average score for text, and then try to use that average score for prediction. You can be clever, of course, have a weighted score or other things. People at Yale Management School and Chicago Booth Business School, they're trying to do this much more clever way. They already have a patent for their article. This is what I know, like last year, I invited them when I was at Ohio State. So people are in text analysis working on like super clever ways of predicting certain stocks. So it's kind of interesting. I don't know whether you can use as a portfolio selection. This is much of an interest for me. I mean, rather than a certain stock, can I kind of go to a large stock market and pick my best stocks according to text analysis? I don't know. It might be more difficult. I mean, there are certain things that people do that well, but I mean, why text analysis is working well? Whenever you read newspapers like Wall Street Journal and others, you kind of see that like there's always like this sentiment one day before the stock goes up and down, and something happens, and the newspapers start writing on them, and then that's reflected in the stock price, I think. So you kind of see that in their forecast. So they captured that, this text analysis. So there are people working on Federal Reserve and other places that I handle their papers in Journal of Econometrics, and they're making good contributions. Also in Europe, I think, and they're trying to make contributions about this, like fundamentals, some indices, and trying to predict some measure. I mean, so the text analysis is all about reading newspapers, like going through the newspapers very fast through the algorithm, and then try to make a point about what will be the certain stock or variable. So this is all about text analysis and machine learning. And of course, I mean, the big issue is like a lot of the places, like 2-3 years ago in Europe, I don't know the other countries, I was mostly involved in Italy. So the conference that we had was a European-wide conference, and then it was opened by Vice President of the Bank of Italy, and he kind of told us that the new oil is the big data. So that's a big word. I mean, so it's kind of like it's very important. So the data sets are helping us in getting much better information. I think what's going on is now we can get the signal better than noise. Before, if you go 20 years, I don't think we could have done that. Now database things are getting dominant, and then and it's spilling over to I think like micro theory. So like I had a visiting job in Columbia 2 years ago, and then I met this micro theorist, behavioral economist, and then we started talking, and their interest was on more like machine learning and then human behavior. So the idea is like as human beings, should we lie to the machines? Is it in our interest to lie to the machines to get a better outcome, or like as a systems analyst, can we kind of like tweak the machine in such a way that even if we lie, we know that we will be worse off, so we aren't gonna lie. So can we create a disincentive for human beings not to lie? So we started writing articles on these things, and then it's kind of interesting. Then it kind of like we realized that the enemy of the machine is overfit. So we try to prevent overfit. So we realized that choice of so-called tuning parameters is not sufficient. So we have to do better. So we propose something else, like how to choose different the tuning parameters in Lasso specifically, so that the people don't lie. They don't have incentive to lie. So people are writing papers on this. I think from Berkeley and Brown, we have seen that more on the, again, in micro and econometric side. So these are interesting developments. I mean, they're all like going through big data, Lasso-based things. And like I said, Lasso is parametric. So if I come back to, in a few minutes, random effects and random forest and deep learning, they're more, I will say, like more like a non-parametric econometrics. I teach deep learning too a little bit. Deep learning is very clever. I will say it's really artificially intelligent. So why I say that, because if deep learning is toward better forecasting, and if the idea is if your forecast is going bad, and then the deep learning goes back and tries to fix that through checking the gradients or the partial derivatives of your forecast with respect to your parameters. So it goes in the reverse direction. So if you're making a mistake, it starts going in the reverse direction so that it corrects the mistake in the forecast. So it's artificially clever. But then one big thing about deep learning is I think there's so many issues in deep learning. There has to be like input variables like we have in least squares. There's an output, but in between there are layers. And in the layers, there are equations, and equations are governed by parameters. It's not clear how many you need them. It's not clear how many layers or equations you need. So all these unknown quantities, parameters, there are a huge number of them. It's not clear how you select it. So I think that's a big problem. And when we try to apply this to finance, it didn't work very well as a tool on its own. So maybe the idea is use deep learning in some like discovering an expectation rather than using as an output as an objective function. So it might be better to use as an intermediate step rather than a final step. So like in finance, for example, I think my co-author, Özlem, in Ege University, she's here too. She's also one of the persons in this article that we published. The big idea was, even for Lasso, which is parametric, to use the technique and then put that technique into the financial theorems. So financial theorems already is near the output. So intermediate step is Lasso. So maybe deep learning will work better, I think, as an intermediate step or a first step rather than the last step. But of course, this has to be tried. I mean, industry, like financial industry, Wall Street, and they're already working on these things heavily on deep learning, neural net. And at one point, I talked to one of the hedge funds in New York, and they were heavily believing in neural nets. And one difference that they have that we don't is they have large data sets, so they buy data sets with money, and they clean them. So they say like 90% of our job was cleaning the data set. And the one that I talked to was working on with computer scientists and statisticians. Actually, one of them was Turkish, from Turkey. And I think he graduated like a chemical engineer from Bosphorus University, and then came back to US, did some MBA, and then started writing these things in hedge funds. So there are research units also in the hedge funds, and then they're, I think, kind of like interested in these neural nets. But like 4 years ago, I think when I read their like decision, not the one that I took, but like there was a book that JP Morgan published, and then I was able to get that one, and then kind of showed that like what surprised me was they had Lasso, deep learning, and everything, but the decision making was incredibly simple. So the decision making was like, if this is above this level, buy the stock. So to me, that doesn't seem right, because like why that specific threshold that you're picking? Why I'm buying the stock if you're above that level? That doesn't make any sense. There has to be a better like a decision rule. So decision rules seem to be incredibly simple at least in the book that I have. Like that really surprised me. I mean, like, and then when you look at the results from Lasso and others, it didn't do very well. That didn't surprise me, because I mean, decision was like crazy simple. So I think maybe it should be a hybrid approach. It shouldn't be like use machine learning on its own all the time, like this industry guys were trying. Maybe you have to use the machine learning as an intermediate or like beginner step towards an output. Output will come from the industry, like finance or your intuition or whatever. Maybe that will give a better answer. Thank you. I think this is it. I think I'm almost like 2 minutes before my time.
Okay, thank you very much for this informative history of this new topic, maybe we can say. As far as I can understand, actually big data opened all this literature.
Yes.
And data deciding everything is a very big difference.
That's exactly the point. I mean, one thing that I didn't mention is like, I can give this as anecdotal evidence. So there was like a lunch in Columbia, and then like all the faculty attends that. This is every week, and there were 2 visitors, us, me and my co-author, and he's a microtheorist, and there was I think a macro guy or another micro guy from Columbia, and like the Columbia guy tells us like, oh, this is not, I don't believe in big data, it's not going to make a big difference. And then my co-author tells to other guys' face that whatever we do, big data will destroy your theories. So this is like blunt fact. I mean, I don't know whether that will be true, but like I'm somewhere in between. I don't think the existing theories are doing a good job, but just pure blunt force big data, I don't think it will maybe give you too much too, but maybe it's somewhere in between. Maybe big data should be used, but not like, I mean, the issue is a horse race, right? Like if I use big data only and I get a better forecast than your structural model in economics, should I abandon the structural model? If I do that uniformly, yes, maybe you should. If I don't, then you shouldn't abandon your model. Maybe you are trying to do a hybrid approach. And people in macro, like in Oxford and Penn, they were trying to do that. They were trying to infuse big data into macro. Mm-hmm. I don't know how they were doing that. At one point, I knew it, I forgot, but like it's not my topic, so I don't. But there's also like I think in Europe, I see Norwegian Business School, for example, and other people, macro people, they're trying to, in Oxford and Imperial College in Europe, they're trying to kind of do this macro/big data approach. And Steve Hansen was my keynote speaker from Oxford at that time. So Steve Hansen was doing that. And I think in Turkey, it might be closest person might be Refet. I don't know whether he does that. So, I mean, this is kind of like the thing. Yeah, big data might be seen as an alternative to existing theory.
Mm-hmm. There was a problem mentioned. Most of the big data is unscattered. So computer engineers are working on it in order to make the data scattered so that it will be more suitable for an analysis. Is that going on? I mean, is unscattered data really a problem for analysis?
Yeah, I mean, according to the industry, yes. Yeah, industry does that. I mean, like I said, the hedge fund that I talked to, this was their job, like cleaning the data set. So they had like raw data, they had satellite dish data. So they had large money. So what they do is they go to some company, and the company gives them satellite dish data overseeing the parking lots of the supermarket. Mm-hmm. And from the parking cars before COVID, they were able to analyze, like, if there are too many cars, there are more sales kind of idea.
Mm-hmm.
So, I mean, and then they were cleaning up the data so that they can do prediction.
Mm-hmm.
So I mean, at least in schools that I'm employed in, I have never seen anyone doing that. But in the hedge fund that I talked to, yeah, they were doing that.
Mm-hmm.
Maybe in bigger schools with more money, maybe they are doing the same thing, like cleaning up the data.
Mm-hmm.
Because the better data set will give you a better answer. It's obvious.
Mm-hmm. Yeah. Okay. Now I want to open the floor to the audience, and I want to take the questions from the audience. Okay, Hüseyin Güler, I think he has a question. First, let's take it. Yes, the floor is yours, Professor Güler.
Okay, thank you, Professor. Do you hear me?
Yes, we can hear you. Mm-hmm.
Okay, actually, I was introduced with the Lasso during your speech in Denizli. It was a long time ago. I was studying reach estimators during those days. But after your presentation, I just realized that Lasso is a very powerful estimator. But we just studied it, like, for example, we provided a restricted version of Lasso and breach estimators. And with one of my PhD students, we just developed a seasonal unit root test and multiple unit root tests with Lasso. However, I had the problem of the selection of tuning parameter. You know, even if you use data to select it, you still need to use some information criteria like modified EIT and etc.
Yes.
So are there any improvements about choosing the tuning parameter, because it determines everything, you know?
I mean, we use like this information criteria in our papers. Like you can use BIC, for example. BIC, when we used it, it didn't make a bad impression on us. The other possibility is the computer programs are using cross-validation, like 5-fold, 10-fold cross-validation. So I think if your aim is for prediction, I think it's better to use cross-validation. But if your aim is for estimation and things like that, I think maybe the better one is the information criteria. But just from what I see, the difference is not too much. But usually information criterion is slightly better than cross-validation, because whenever we use in these things in different contexts, and then we do horse race sometimes. So I have a paper that does that in a finance paper. There's a horse race, and I think information criterion is slightly better. I might be wrong on that, but this is what we see, yeah. But not necessarily BIC. Not necessarily BIC. We developed something called GIC, Generalized Information Criterion. It kind of penalizes things slightly differently. So it penalizes the system better, I think. So I think there's a paper by us in 2018 Journal of Econometrics. If you look at that paper, that's in my website. It shows how to do that. So it might give a better answer. But yeah, another alternative is cross-validation.
Okay, thank you. And my second question is, in your paper with Knight in Statistical Planning and Inference, you did not make any hypothesis test because there is no limiting distribution. But is it possible to apply a bootstrap method or something like that, for testing the Lasso parameters?
No, I don't think bootstrap works. I don't think bootstrap works with Lasso. I think there was a paper on these things, and no, unfortunately not.
Okay, thanks so much.
You're welcome.
Okay, thank you very much. And I think Mustafa Özer has a question.
Yes,
yes, we can have the question.
Okay. Hi, Professor Caner, thank you for the presentation. As far as I understand, machine learning is developed mainly aiming to solve like traditional econometric model approach main problems like regression-based variable selection and dealing with the nonlinearity and etc. So my question is, most of the models that you're using, and you mentioned like Lasso and the rich regression, are the linear models. So if there is a like non-linearities in the relationship between the economic problems, how do you deal with these non-linearities within this machine learning framework? That's my first question. Second one, and can you give us like some information about how to carry out like robustness checking, especially comparing to these machine learning models? Thank you.
Sure. Yeah, good questions both. So the first one is like nonlinearity. So I worked in these nonlinearity stuff before, and we published like exactly this kind of stuff. We published in one article in, I think, JBS, Journal of Business Economics and Statistics, in 2015 or 16, or it might be even 17, I can't remember, with Assoc and Laurent Callot, how to do this in nonlinear threshold regression. So we proposed a nonlinear threshold regression based Lasso. It gave better results than existing estimators. But I mean, even though I have published that article and that was my idea, I remember that. I'm thinking like you can always write any kind of like unknown function as a infinite degree polynomial linearly, and then what you can do is you can run Lasso on that infinite degree polynomial. So maybe again linearity dominates. I mean, in the sense that even though I published this nonlinear article and my other articles are linear, and if you look at literature, statistics literature, a lot of the articles are linear. So one constraint that a lot of us, I mean, like I said, the general issue is you can always think any function as a polynomial, and then run Lasso on polynomial. So this will be pure linear, large scale linear system. But if you don't like that approach, I think the idea is like fit something like we did in JBS. We started with a threshold regression, and threshold regression, instead of testing the threshold, it was able to see whether the system is linear or non-linear as well as estimate the system. So it was very general than my other papers. And so the answer is like you can fit something very general like we did in that paper, and then some kind of non-linear generality, and put as a subset linearity, and then you can see it. So we did it in thresholds. I don't know whether people did it in other non-linear contexts, but yeah, I mean it's correct. So if the truth is very nonlinear, yeah, Lasso can miss it unless you do some thresholding or some other, like maybe random forests might be a good idea, because random forest is kind of like a nonlinear trick, basically. But in forecasting, my students, they got horrible results with random forest. Yeah, I mean the robustness check Lasso against others. Yeah, my students also did this in the last 2 years here in North Carolina State. I mean, it's difficult to judge these things in my view, like one against the other, but deep learning is giving good results. But I will qualify that statement too, because when we use deep learning in finance with my former postdoc against Lasso-based things, deep learning didn't give good results in real life. So I don't know. I mean, it's difficult to judge. I think you have to do simulations, and then we have to make that the horse race in the simulation is really one-to-one comparison, not apple to orange comparison. So I have never done that myself. I compared Lasso to Lasso. I never compared Lasso to others. But in terms of robustness checks inside the Lasso against like the regular models, without doing any model selection, yeah, Lasso dominates, definitely, yeah.
How about the correcting problems like multi-collinearity, for example, in the large panels?
Yeah, I don't have a good answer to that. Okay. Multi-collinearity problem. Yeah, I cannot think. I mean, the best answer will be like using ElasticNet, right? Okay. So I published something called Adaptive ElasticNet, and Adaptive ElasticNet gave good results. But even though I remember, like in the simulations, we proposed some like large correlation among the right-hand side variables, Adaptive Lasso still did very well. So that surprised me. I mean, like if you look at, we published like 2 articles called Adaptive ElasticNet with GMM, with Helen Zhang, again in Journal of Business Economics and Statistics, and then we published like recently, again in JBS, adaptive elastic net that can tackle like invalid instruments and then weak instruments, so on and so forth. So there's like a very nice estimation technique that we propose there through adaptive elastic. So it can handle multicollinearity in that sense. But I mean, if you ask me, adaptive Lasso did better.
Could it be reason that Lasso provides less coefficient than the others? In terms of dealing with
the issue with Lasso is this: say that there are like two regressors, they're highly correlated, and say that they are both x1 and x2, they're highly correlated, 0.9 for example, and then they both predict output. Lasso will make the mistake of dropping one of them. Elastic net or adaptive elastic net will keep both of them. So if both of them are highly correlated, but both of them are contributing, both of them should be included in your regression. So elastic net will keep, I mean, there's an article in the literature before us, elastic net kind of gives extremely well result in linear systems. In the nonlinear systems, I didn't see that. But in the linear cases, yeah, there's a case for using elastic net. So elastic net protects against multicollinearity. So maybe I should qualify my earlier statement that I didn't know. Yeah, I kind of know, but only in the linear context. I think elastic net will solve this problem of yours, or adaptive elastic net, to be sure of model selection issues.
Thank you.
You're welcome.
Okay, thank you. I think we have another question from Professor Saud.
Thank you so much. Marhaba from Pakistan. This is Dr. Saud Ahmed Khan. Thank you so much, sir. Nice lecture. Nice, you know, for you. I have a question, like how you compare the Gauss type models with machine learning techniques, provided we know that the financial time series have very specialized, stylized features as compared to the other time series.
No, I didn't hear the first part of your question.
My question is how you compare the Gauss type models with the machine learning techniques.
Gauss type?
Gauss type models. Gauss type models.
Oh, Gauss type models. Okay. Yeah, that's a very good one. I mean, I'm thinking, yeah. Actually, I wanted someone in Turkey to write a paper about that, and he didn't want to. So I don't know the answer to that. But maybe, I mean, what might possible be like, you can take a Gauss type model. This was the idea that I had. I didn't write this paper, but like, take a Gauss type model. There are like legs and so on and so forth, Gauss PQ or whatever. And then model selection, Lasso can help you to select the better legs and estimate the model simultaneously. I don't know whether anyone is doing that. I have no idea. I mean, so it will be interesting to see. But I mean, Lasso and like all these machine learning tools are model selection tools, basically. And then it helps you also in estimation and prediction as well. So if you believe your model is correct, and then one better way of checking it is like through this model selection toolbox. But I don't know about Gauss and machine learning. I haven't seen anything like that. Maybe there's some paper out there, but I don't know.
Thanks so much.
You're welcome.
Okay, thank you very much. Any other comment or question? Okay, I think we don't have any more questions. As far as I can realize, there are some students in the audience. So to them, I would say that this is really an open area to study. So after this informative history, you can, I think, go on your research in this new area. Maybe Gauss type models you can study. Okay, thank you very much for your informative speech. I think we gained a lot.
Thank you. I mean, I have like maybe one or two more sentences. I think like if you're not a theoretically consumed person like me, I'm really interested in technicalities. and writing technical things and such and so forth. And if you're not like me, I think there is still room to do research in this area, because I think this will be I'm thinking like in the 20th century, we did standard econometrics without any model selection. And now it's 21st century. And I'm thinking like, this is the century of big data. It's not like a fad. There are a lot of fads in econometrics, like weak identification, partial identification, now like this randomized trials. They're nice stuff. They're all fading usually. And I don't think big data is fading. And the reason is computer science and statistics are so strong, giving us this foundation. And the issue is whether it will be amenable to use in economics and finance. And we see that its usage is improving economic understanding and financial understanding. So what I'm trying to tell is, you can always look at like my papers and Victor's papers, and there's the paper, panel data papers by Su in Singapore, now maybe in Tsinghua University in China. And there are papers by Alex Belloni at Duke, more on the financial side. And then there are so many papers are written, and then you can apply them to different data sets, to different problems in your country, and get answers. So this is all open. This is all open. This is all new. This is all open. It's new. It's all open. I mean, you don't have to know the technical details like us. There might be a lot of applied econometricians, and then you can just use the paper as an applied project. So like one of the papers that we have written in GABS, we are using as a applied tool now.
Yes. Okay.
It looks complicated, but it's not. It's just I mean, the issue is you need to understand what is going on. It's a penalized regression. A lot of these things are penalized regression. It's nothing fancy. It's just like technicalities are slightly fancier, but it's a different standard toolbox. And everything is open source in R or MATLAB or Python, I think. So go ahead and then try your luck, I should say.
Yes. I also agree with you.
I think we should have a like big data conference in Turkey at one point after COVID.
Yes, after COVID.
We should have something like that.
Yes. We can do it, I think.
Like 2022, yeah, sometime, yeah, summerish.
Yeah, a very good idea.
Yeah.
We can do it.
Yes.
Okay. Once more, thank you very much,
You're welcome.
to you, Mehmet, and also to all of the audience for attending. I hope to see you again in our next AYBU ERA conference, which will be announced later. So have a good have a good night. Let me say, and goodbye for the time being.
Thank you.